So the topic that we chose as a group for our final project is exploring sequences. Definitions. A sequence is a list of objects in a specific order, and some of the symbols and notations used is an, which is equals nth term of the sequence, and an minus 1, which is the previous term. Nth term formula is a formula used to find any term by plugging in its position number n. Recursive formula is a formula for the next term using the previous term. A difference table is a chart that shows the difference between consecutive terms repeated until a row contains all the same numbers. In this slide, we're going to go over the formulas. The nth term formula is used when you want to find any term in an arithmetic sequence without having to write out every single number before it. You just plug in the position number, or n, along with the first term and the common difference. It's really helpful when you're trying to find a term that's far into the sequence because it lets you jump straight to the answer in one step. The recursive formula works a little differently. Instead of jumping to any term, it builds the sequence one term at a time. It tells you the next term by using the previous one and then adding the common difference. So with this formula, you can't skip ahead. You have to move through the sequence step by step. Both formulas describe the same pattern, they just give you two different ways to get the value you want. One is fast and direct, and the other is more gradual and shows how the sequence grows.
Example number 1. Observe the hexagons. When looking at these hexagons, each hexagon has 6 sections, with one of those sections being shaded. Let's look at the shading pattern. So, in this problem, we're trying to figure out what the shaded box will be for the 4th hexagon. On the first hexagon, we see that the top left section is shaded. Then on the second hexagon, we see that the bottom left section is shaded. Notice how in this pattern, we see that the shaded sections are moving to the right. Then we see it again with the section being shaded on hexagon number 3, which is now in the middle. So, what section will be shaded next? We could use inductive reasoning to figure out the pattern sequence and see that the next section that will be shaded is going to be the bottom right section.
A difference table helps you understand how a sequence changes term to term. The sequence seen here is 2, 5, 8, and then 11. We list each term and figure out the difference between consecutive terms. If we do that with this example, we can see the difference is the same each time, that being 3. The recursive formula uses the previous term to get the next term. It's recursive because it recurs, meaning it repeats the same steps over and over. The starting value is 2, and the rule for finding the next term is an equals an minus 1 plus 3. So to get the nth term, take the previous term or an minus 1 and add 3. And you can see that'll get us 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, and if we want to go one further, 11 plus 3 is 14.
Hey everyone, today we're looking at example number 3, how to find the nth term formula for the sequences. First, we have a sequence of stars. You can see the pattern. Each term has one more star than the last. The first term, A1, is 1 star. The common difference is how much it increases each time, which is 1. So for the formula of the sequence is an equals to a1 plus n minus 1 times d. And that turns into a1 equals to 1 plus n minus 1 times 1, which simplifies to an equals n. So we want the 5th term, a5. We plug in 5 and we get 5 stars. Now to look at the number sequence 3, 7, 11, 15, this time the pattern is increasing by 4 each step. So a1 equals 3 and the difference is d equals 4. Using the same formula, an equals 3 plus n minus 1 times 4. If we want a6 for the 6th term, we plug in 6, 3 plus 6 minus 1 times 4, which equals to 23. So the sixth term in that sequence is 23.
Okay, so looking at sequences in everyday life and how to identify them, you can think about stacking chairs. Each new row adds to the same number of chairs. This is an example of a rhythmic sequence because the amount increases by a constant value each time. Now, considering saving money, when you make consistent deposits, your balance grows in a predictable pattern. This is a geometric system where each step multiplies by the same factor. To recognize the difference, arithmetic sequences involve adding or subtracting the same number each time, while geometric sequence grows by multiplying a consistent number. Understanding these patterns help us understand the sense of real-life situations involving steady change.
So to conclude for our summary, we showed sequences that follow a pattern, recursive formulas that help find the next term. We talked about the nth term formulas that allow us to find any term directly, and also about the difference tables, which help identify the patterns.